these by distributing. So distribute the 2 in, and then the 3 in as well. So when we do that, we're multiplying. Once we're to this point, we want to get the x's on the same side of the equal sign. Right now there's an x on each side. So I want to move the smaller x over to the other side. So I'm going to move the 2x over. It just kind of, in this case, it will save us a whole step because I'm getting rid of that negative, or there's not going to be a negative. So to move it over to the other side, we subtract 2x. So 3x minus 2x is 1x, or just x. And then to get my excellent, I'm just going to move that 24 back over. So x is going to end up being negative 32. Okay. So the reason we're learning this today is we are going to, or that we reviewed that, is because we are going to be using things like that in our notes today. So I guess when I said we were going away from it, we're kind of, I guess maybe more adding on again. So, and this is probably something you've seen before, but there's also a lot of misconceptions that come from proportions and also percents. So both of the things we're talking about today are things I know you've learned, but maybe have gotten some things jumbled up or some ideas confused about them. So a ratio is a comparison of values. So when we talk about a ratio, and you see ratios all the time, it's a comparison of values. You just might not realize that's what you're seeing. So like when you guys got your test back and it had a number over the top of another number, that was a comparison of values. That was the number of points you earned versus total points. That's a ratio. So we can see it as, I'm just going to write it with like variables, so like A over B, or you can write it as like A dot dot B. If you're into sports, they use ratios a lot when they talk about like a shooting percentage or a hitting like percentage. Like those are all ratios. How many times you get a hit versus how many times you're at bat. It's comparing two values. And now you might already be thinking then, well, if it's a fraction like that, usually you write it then as a percent. A lot of times you guys divide those numbers and you figure out what the percent is. And because the ratios and percents are so closely related, a lot of times we teach them on the same day, which is what my plan is today, as long as we do fine on time. Now, so that's just a ratio in general, but then a proportion is when I set two ratios equal. So a proportion is two equal ratios. And a lot of times we see these as fractions. And actually, when we talked about multiplying fractions, I don't remember who said it or, like who had the misconception. When we were multiplying fractions, somebody at some point said, oh, do we need to cross multiply? This is actually where we get to cross multiply. Multiplying fractions we didn't get to. Here we can actually cross multiply. And then we set them equal. So we're going to multiply the diagonals together. So the way this is different than we were talking about before, this is an equation versus just being multiplication. So we cross multiply and set equal. Alright, so the next couple questions ask if the ratios or if the proportions are equal. Or equivalent, which just means equal. Are the ratios equivalent? So basically, is this a true statement? Does 4/6 equal 6/9? So basically, is this true? That's kind of what they're asking another way. So equivalent just means equal. So does 4/6 equal 6/9? You think so? You don't think so? Okay. Anyone? It's either yes or no, right? How would you check, Trista? What would you do?
I divided 6 times 6 divided by 4 and then 9 divided by 6.
So yeah, she only thing is you probably wanna flip that, but yeah, it still works. But if you wanted to actually check what the decimals are, you could do 4 divided by 6 and then 6 divided by 9 and see what that is. Now that might be tough if the decimals are really, really weird numbers. These aren't terrible. So just careful that if you're looking at this as a fraction, it's 4 divided by 6, even though that seems strange. But what we can do, maybe a little bit easier than, because 4 divided by 6 in my head, I know what that is just because I do math all the time, but that might not be a fraction you know the decimal equivalent for. So what we can do instead is we can check the cross products. So we can check what happens if I multiply. What if I multiply 4 times 9? Does it equal, it's a question, 6 times 6? You sure?
I said no.
Yeah, I said, are you sure? 4 times...
I thought it was 3.
No. So 4 times 9 is 36. And then 6 times 6 is also 36. So they actually are equal. Now, what Trista did when she checked the ratios, just by dividing them, it's fine. That works just fine as well. But if I cross multiply, they better be equal if I say they are. So we'd say, yes, these are equivalent because 36 equals 36. So this one would be a yes. Now how about the next one? I say they're equal, but are they? Sometimes things are false. So we check the cross products. So I have 5 times 4. Does that equal 2 times 25? No. 20 does not equal 50. So this is not true. So this one's a false. So if they asked you, are these equivalent, you'd say no. So you can check them that way. Now, if they're asking you to solve, in the next few problems, we can assume they are equal. They're not trying to pull our leg on this. So they should be equal. So in order to solve something like this, we're going to cross multiply. Now, I remember when I first learned proportions, someone told me, oh, you always just cross multiply and divide. That works really, really nicely for this problem, but it stops working after that point. So I'm just going to give you just a quick tip on that, just that if you've heard cross multiply and divide, it works for one type of problem and then that's it. And we get into more complicated problems than just like letter A. But we can do that. We're gonna use the cross products. So we're gonna cross multiply. So I'm going to multiply n times 8. So I'm just going to write that as 8n. And then I'm going to multiply 12 times 3. And that is 36. So now to get my n alone, I have to do what? What do I do to get n alone?
Divide.
Divide by 8. Now that might be freaking you out because you're like, oh, that's not a nice number. That's okay. Don't get worried about decimals at all. So 36 over 8. It's 9 over 2 or 4.5, right? Is that what you guys got? Right? Yeah, okay. So let's speak up. 4.5, and that's fine. Sometimes my mental math in the morning is not strong. It's not strong in the afternoon either, but so I make mistakes, especially in front of you guys. So stop me if I multiply wrong or divide wrong. So we solve for m there. Just becomes a 2 or a 1-step equation pretty quickly. Now letter B gets a little more difficult because now when I go to cross multiply, I'm multiplying that 4 times the x plus 4. How do I show in algebra that I want to multiply 4 by both of those? What symbol did they give us to help us with that? What do I need to use in this case to show I'm multiplying those two together? Anyone know? What do we need in this case? Anyone able to? I know some of you guys are working ahead trying to see if any of you guys. Anyone? Can I see if anyone knows and just is afraid to speak up? No? Okay. So if I want to remember to multiply 4 by x plus 4, I want to use parentheses in this case. Because there's those two terms there, I want to multiply 4 by both of those. So I'm going to put that in parentheses. Does that make sense that I want to distribute that 4 into both of those? So that's where the parentheses are important. And then 12 times 3 again. So I distributed that 4 in. Guys, make sure you're taking notes with us, please. So if we had a notes quiz, I wouldn't want you guys to have to try and remember all this. We're probably having a notes quiz next week at one point. We're going to be getting close to the end of the chapter. Same thing goes for those of you guys online. Make sure you're taking good notes. So that cancels. So I get 4x equals 20. This is 36 minus 16. And then I'm able to divide by 4. So the value that works for us is 5 in this equation. Is that okay? So we'll do a couple more and then we'll take a break from notes here for a little bit. So this next one in C, we have to cross multiply again. But this time when I'm cross multiplying, I'm multiplying that 10 by the 2n minus 4. So again, I want to use parentheses here. Same thing on this side. So cross multiply, I'm going to need parentheses on both sides this time. Just to remind me that I have to distribute that 10 in, I have to distribute that 5 into both sides. Yeah. So we're going to distribute. Distribute. So at this point, guys, we're ready to bring our ends together. So I want to move the smaller of the two ends. So I want to move that 15n over. And then I'm going to move that 40 over to the other side. Bless you. And then to get my n alone, I have to divide by 5. So yeah, I guess this kind of is a problem that's really disguised a lot like what we had yesterday. It just starts off a little bit different. So n ends up being 11 there. And finally, we'll do letter D. And then we'll grab some whiteboards for a little bit. So here, again, we have to cross multiply. And just so you guys know, it doesn't matter which one you put on the left side and which one you put on the right side. It won't change anything. So if I'm not being consistent about that, it's just really because it doesn't really matter. I don't know if I do it one way or the other. But 5 times n plus 2. And then the 3 times n could just be 3n. I don't need to really do much with that. I can just kind of combine them the way they are. So I'm going to distribute there. No. Oh, yeah. High alert. So I distributed. Now in this case, I'm going to kind of break my rule of moving the smaller variable. Oh, did I do something wrong? Are we okay? Now on this one, instead of moving, I usually tell you guys to move the smaller variable. Why don't I want to do that in this one, you guys? Yeah, Lucas?
Because then there wouldn't be anything on the other side. So
Yeah, this would be kind of like empty over here. So since this is already alone, I'd prefer to move the 5n over. I know it's not ideal. It's kind of, like I said, it's kind of breaking my rule, but that's why I don't write it down as a rule, because it's kind of just more like a suggestion, I guess. I'm going to move the 5n instead, so that then the n's alone with the other n. And then to get that n alone, I'm going to divide by a -2. So I find out n would be -5. Alright, so if you guys want to take a minute to grab whiteboards, please. Why don't we send this half of the room first over here? I'm going to stop the video.